In this video, we'll take a look at the perimeter and area of similar figures. First, we'll start with the area of similar polygon theorem. If two polygons are similar with lengths of corresponding sides in the ratio of A to B, then the ratio of their areas will be A squared to B squared. Remember, area is usually two dimensions that are multiplied together. So that's where that squaring element comes from. Find the ratio of the perimeters of the red triangle to the blue triangle. So when we take a look at our first example, red to blue, my ratio is 8 to 12. We should absolutely simplify that. So I'm going to divide top and bottom by 4, and we'll get a ratio of 2/3 for that. That's the perimeter. So when we take a look at the area, it says find the ratio of the areas of the red triangle to the blue triangle. Well, if we already know our side lengths are in a ratio of 2 to 3, then we can go ahead and say our areas are in a ratio of 2 squared to 3 squared. Therefore, the ratio of the areas from our red to our blue triangle will be 4 to 9. The perimeter of triangle ABC is 24 feet, and its area is 24 feet squared. The perimeter of triangle JKL is 36 feet. Given the triangle ABC is similar to triangle JKL, find the ratio of the area of ABC to the area of JKL. Then find the area of JKL. So first we're going to take a look at the ratio of the perimeters of these two triangles. And again, we're going from triangle ABC to JKL. The perimeter of ABC is 24 feet. The perimeter of JKL is 36 feet. So I think we can start there. We can say 24 over 36, and then we can reduce them. 12 goes into both. So I think we have a ratio of 2 to 3. So we know the ratio of the perimeters is 2 to 3. I'm going to use that to then build my ratio of my areas. So the ratio of my areas will be 2 squared over 3 squared. And we found this on our previous example to be 4/9. So that's the ratio of our areas. If we want to find the area of JKL, I'm going to use that ratio that we came up with. We said the ratio of the areas is 4 to 9. I want to find the area of JKL. I already know the area of ABC, which was given to me in my problem as 24 feet squared. So if I want to find the area of JKL, I can set up a proportion. I can cross multiply and divide. I'm going to multiply by diagonals. 9 times 24 is 216, which is equal to 4x, the other diagonal, multiply. Divide everywhere by 4, and we'll get our x, or our area of JKL, to be 54. But it's not just 54. In this case, it's 54 feet squared. So first we found the ratio of our perimeters, and then we found the ratio of our areas. And because we were looking for area, we then used that ratio of the areas to create a proportion to find the area of JKL. Let's take a look at our next example. It says the ratio of the areas of two regular decagons is 20 to 30. So that's already the ratio of the area. What's the ratio of their side lengths? If we want to find the ratio of the area of the side lengths, originally in the previous example, we started with side lengths and then we squared it. So here, if we're already starting with the areas, then we're just going to take the square root. So I'm going to start off with the square root of 20 over the square root of 36 and see if I can simplify to get a ratio. The simplification of square root of 20 will be 2 radical 5, and the square root of 36 is 6. We can simplify this further to find our ratio, square root of 5 over 3. Our next example says, given the figures are similar, find the area of the smaller figure. Well, what we have for both would be their side lengths. So we can start with a ratio, and I'm going to go red to blue. I'm going to start with 7 inches to 9 inches, and I'm going to square them. So 7 squared is 49. 9 squared is 81. So that's the ratio of the areas. Now I know the area of the blue shape is 210. So I'm going to put that in, and I want to make sure I put my area of the blue shape in relation to where I put both the side lengths for the blue shape. So I put the blue shape on the bottom of my fraction, squaring the side on the bottom, so the area will also go on the bottom. So now we can go ahead and do some cross multiplying. I'm going to take 49 and multiply it by 210. Because this is my x, so that gives me 10,290, and that will be equal to 81x. So I'm just going to take my 10,290 and divide it by 81. And I'm going to find my x, which is my area of my smaller figure, to be 127. I'm going to round it to the nearest hundredth here. Would be 0.4, and that would be inches squared. You could have rounded this to the nearest whole number. It didn't specify, so we'll want to make sure we're specific in our directions on tests and quizzes and things. When we take a look at our next one, it says, given the figures are similar, so that's really important. We need to know that these shapes are similar. Find the length of AB. So this is a side length we're looking for here. Well, they gave us the ratio of the areas. So I'm going to call this shape 1, shape 2. I'm going to go from 1 to 2. So I'm going to say the area of my first shape, and I'm going to take the square root, so I get the side lengths, over the area of my second shape, like that. So I'm going to go ahead and have to do some simplifying here. All right, so we have the square roots of our areas, and we're going to go ahead and simplify each of these. So when I pull out 128 and start factoring, I know it's 2 and 64. So 64 is my perfect square. So this becomes 8 radical 2. On the bottom, I have 18, which I know is 2 times 9. 9 is my perfect square. The square root of 9 is 3 radical 2. This is nice. I have radical 2 on the top and bottom, so we can cross those out as we simplify. So now we have the ratio of our sides of 8 to 3. So now I'm going to take a look at what sides I do have. I don't have AB, that's the side we're looking for. That's from my first shape, so that's where my x is going to go. And on the bottom, I'm going to have 4, which is that corresponding side in my smaller shape for my second shape. So here we just have a proportion we're going to solve. 8 times 4 is 32. Which is equal to 3x. Divide by 3 everywhere, and you'll find your side length to be approximately, and we're going to have to round this. I'd round it to the nearest tenth for this because it's a repeated decimal. We've got, and I should actually do maybe these approximate signs instead. It's approximately, because we did round, 10.7. Okay, let's take a look at our next few examples. These are the U-tries. So what you can do is pause the video and go ahead and try them on your own, and then unpause and see how you did. All right, when we take a look at these two examples, we've got, given the two figures are similar, find the ratio of perimeters and areas. So we'll start with that. So my perimeter, and what I did was I named my two shapes, A, B, C, D, or A, B, C, I named shape 1, D, E, F, I named shape 2, which is the order that it's given to me in my problem. So when I take a look at the perimeter, I want to just look at my side lengths, compare my side lengths. So for A, my ratio is 12 to 15, or perimeter, excuse me, is 12 to 15. We can reduce that to 4/5. So that is the ratio of the perimeters. The ratio of the areas, I now take that perimeter ratio and just square it. So I have 4 squared and 5 squared. I get 16 over 25. That's the ratio of my perimeters. Now, part 3 says if the area of ABCD is 24, so my area for this shape is 24 units squared, what's the area of DEF? I use that area ratio, 16 to 25, and set up a proportion. 16 over 25 is equal to the area of ABC, 24, over the area of DEF, which I've named X. Cross multiply divide, you'll find the area of DEF to be 37.5 units squared. For part B, we have a word problem with no picture, so it's your job to go ahead and draw a picture. Got a large rectangular baking sheet, that's here, and it tells me the length is 15 inches long and the width is 10 inches wide. A smaller pan is similar to the first, that's good. The area of my small pan is 96 inches squared. So here I have my drawing. And I got stuck to begin with because it's asking me to find the width of the smaller pan. But I don't have any of the dimensions of the smaller pan. But what I can start off with is the area that they gave me of the small pan, and I can compare it or create that ratio to the area of the large pan. So I'm going to go ahead and find the area of my rectangle. Remember, area of a rectangle is length times width. So 10 times 15 gives me my area of 150 inches squared. So now I go ahead and set up that ratio. Again, I described my large pan as number 1, my small pan as number 2, so I can keep that ratio in line as I write my proportions. I'm going to compare the areas first. So I have the area 150 over 96, but I want to find its side length, so I'm going to go ahead and square root both of those. I worked on my square root of 150. I found it to be 5 radical 6. And I worked on simplifying the square root of 96 to be 4 radical 6. Awesome! My radicals go ahead and cross each other out, and I have my ratio of my lengths of 5 to 4. If I know my ratio of lengths, of perimeter is 5 to 4, then I go back to my shape. We're asked to find the width of the small pan. So which dimension was the width of my large pan? Well, it was 10 inches wide. So in my proportion, I've got 5 over 4, which is the ratio, of the length or the perimeter, equals the width of the large pan over the width of the small pan, and the small pan is what we're looking for. Cross multiply divide, you'll find the width of your smaller pan to be 8 inches. Okay, we'll take a look at our last 2 U-tries. We have a rectangular billboard that is 12 feet high by 27 feet long, and a smaller billboard that is similar. It has an area of 144 feet squared. Find the height of the smaller building. So we started off by finding the area of that first billboard. 12 times 27 is 324 feet. So that's where I start with the ratio of my areas. So I did 324 over 144. But if I want to find my side lengths, or the ratio of the perimeter, I have to take the square root of both. So I took the square root of 324 to get 18, and the square root of 144 is 12. So my ratio is then 3/2. I go ahead, it says find the height of the smaller billboard. So the height corresponds to 12 feet, 12 over x. Cross multiply, you get that height to be 8 feet. For the second one, very similar. I found the perimeter of rectangle 2 to be 96. I found its area to be 540. I use the ratio of the perimeters